so we're still on our 6-8 notes. We're on example 4. Who can raise their hand for example 4 and tell me what is slightly different about this example that we have to graph than the ones we were doing on the previous pages? What is different about this one? Very good. That plus 2.5 is inside the absolute value instead of outside of it. If you want to, off to the side here, you could write a little cheat sheet for yourself. If it is outside, we were moving our graph either up or down.
Oh, inside is left, right.
Exactly. Yep. So if that is outside of the absolute value, you're either going to move it up or down. But now on example 4 here, now that it's inside our absolute value, we're either going to move left or right. All right, so the other thing that you have to keep in mind, if it's outside, when we were going up, it was positive, right? And when we were going down, it was negative. You guys all agree with that? Makes logical sense. You go up, you go down, positive or negative. If it's inside the absolute value, because of those absolute value symbols, you actually have to do the opposite of what you would want to naturally do. So, if you have a plus 2.5, naturally, where do you think you need to go? Naturally, you think you need to go to the right, but guess where you actually have to go? To the left. So if you have a positive or a plus 2.5, you're actually going to go to the left. And if you have a negative, you're actually going to go to the right. So it's like the opposite of what your brain would naturally think you need to do. So I'm going to go ahead and make some grid paper for this example here. And I am going to start, it says to graph by translating y equals the absolute value of x. So I'm going to start with my parent function. So go ahead and start with the parent function. Where does the parent function start at? 0, 0, up 1 over 1, up 1 over 1. Yes. It depends. If the directions say graph by translating y equals the absolute value of x, then you do need to start with the parent function. If it just says to graph, then you don't. So this is my parent function. I have the absolute value of x plus 2.5. So that 2.5 is inside. And since it's positive 2.5, naturally, if you look at a number line, positives go to the right, right? But the absolute value symbols make you do the opposite of what you want to do. So we're actually going to go to the left 1, 2.5 spaces. So I'm taking my vertex and I'm moving it to the left 2.5. And then I still need to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Questions on these ones where that is inside with the parent function. All right, let's jump to this next page. So go ahead and graph number 17. Now, do you see on this one, it says to graph the following? This one, it doesn't say using the parent function or using y equals the absolute value of x. So for an equation like this one, if you don't want to draw the parent function, you don't have to draw the parent function. So is that plus 3 inside or outside? Inside. It's inside with the parent function. So we're either going to go to the left or the right. Which direction do we have to go? To the left. Yep. I'm going to the left 3, up 1 over 1, up 1 over 1. So your graph should look like this for number 17. You're taking that parent function and you're shifting it to the left 3 units. All right, example 5. Give you guys just a second. Looks like a few of you are still finishing up that graph. Any questions on this one before we jump to example 5? All right. So for example 5, we have to write an equation for each translation of y equals the absolute value of x. That's our parent function. So if we want to move to the left, naturally on a number line, the left is what type of number? It's a negative number, right? But because of the absolute value, we're going to do the opposite. So we're going to actually do y equals the absolute value of x plus 10. And that plus 10 has to be inside. Because if it's outside, it's going up or down, not left or right. Yes, sir. There could be one where, are you asking, could it be both? Like this? Absolutely. We're not going to get to that, but you will in Algebra 2. You could absolutely have both. All right, so for letter B, who thinks they could help me with 7 units to the right? Come up with. Perfect. X minus 7 inside your absolute value symbols. Very good. And on this last page, you've got one more to try on your own. All right, and who can raise their hand and give me your equation for this one? We want to move it right 9 units. Perfect. X minus 9 should be inside your absolute value symbols. All right, your homework tonight is going to be on your 6-8 worksheet. There will be some that you have to graph. And there will be some where you just have to write the equation. So for homework tonight, I'm going to have you guys do. So for homework tonight, I'm going to have you guys do number 2. 4, 6, 8. All right. I'm going to have you guys try numbers 10 and 12 as well, but I'm going to give you a little bit of a hint on that. What do you notice is happening on 10 and 12? Yeah, they're going both left and right and up and down. So if you see you've got this -2 right here, where does that -2 take you? Down 2. What's that? It's going to have the same slope. It's still going to go up 1 over 1. So you're going to go down 2. And then this +3, where's that going to take you? Left 3. So your vertex is going to go to the left 3 and down 2. And then you go up 1 over 1, up 1 over 1. And you'll do the same thing for number 12. So that's 2, 4, 6. I'm going to have you guys do numbers 3 and 1 as well. So there are 8 that you have to graph. No, I'm not, but you can grab graph paper if you want. And then I want you to do the ones where you have to write the equation. So you're going to have 8 that you have to graph. And then 22 through 30, you can just write the equation on your paper. Yep. All of them for 22 through 30.